Hi, welcome to app number 13, Student Management System. This is one of the best apps in terms of the codes you'll write. The code will be all-inclusive in terms of covering many subjects of Python, such as using classes, using SQL databases, using desktop graphical user interfaces. This time we'll use PyQt6, the latest PyQt library. Now, we used PySimple GUI before, or PySimple GUI, which was a good introductory library, but for professional desktop programs which have a graphical user interface, such as this one here, which we'll build in the next few days, starting from today. So for more professional applications, you will need something like PyQt. So what is this app? Let me give you a short introduction. So the name is Student Management System. It's used by schools to manage student data. So when you open the app, you should see this list of students, their names, the course they have enrolled to, their mobile number, and each of them is assigned an ID. So this app can be used by teachers in a school, so teachers can add more student data. So for example, Ben Smith, they can select one of the available courses that Ben should be enrolled to, like physics, and then you write a number for Ben and so on. So once you press register, Ben will be added to that table view. You can also search for students by name, for example, Andy Johnson, search, and that will select that record which contains that name. You can also update a record. For example, you select on 6 to update that name to something else. For example, you can change the course to something else, press on update, and that record will be given another value for that updated column. Lastly, you can also delete records. For example, let's delete the last item, and that will be removed from the table. So all these data are stored in an SQL database, so this has a professional database backend. So let's go ahead and build this program together, starting from the next video. So I'll see you there. Thanks. Before you build any app which has some sort of graphical user interface, it's good to do some planning before you go into coding. And by planning, I mean making a list of requirements, the project requirements, so a list of things you expect the app to do, and also creating a graphical design, drawing the interface, the graphical interface. So let's start by making a list of the project requirements. And this is more simple than it sounds. All you have to do is put yourself in the shoes of the user. So ask yourself, who is the user first? Well, the user might be a teacher or someone else from the management staff of the school. So let's say it's a teacher, and so what they want to do in the app is first, they want to be able to view students. So that would consist of viewing the student ID, the name of the student, the course the student is enrolled in, and also the phone number. The user should also be able to insert new records. They should also be able to update a record, delete a record, what else? Well, search a record, and lastly sort records. So these are all the requirements that the app should satisfy. So with those in mind, now we can think of a graphical user interface and draw something before we go and code the app in PyCharm. So let's draw some windows in the next video. I'll see you there. Now that we have the project requirements, we are ready to go ahead and create a prototype. So project requirements, prototype, and then coding. So creating a prototype means drawing the windows, the views of your application. So this is the case when you have a graphical user interface. Therefore, in this video, I want to show you all the sketches I've made for this prototype. So you can either use a software to create the prototype such as Figma, or you can draw this by hand as I've done for this video. So I did cover Figma previously in the course, therefore I don't want to go through that process again, so I just created this by hand. You don't have to redraw these, you can just watch this video as I explain what the app will consist of. So as I explain you the prototype. So this is the first window. When the app is executed, we'll see this. So we have the menu items here, file and help. Then we have the toolbar, so that will be a button which will add new records in the table here, and this button will open a dialog window where you can add a new record to this table. I will also show you how that dialog window looks like, so you also have to document each of the windows in your prototype. But let's focus on this window first. So we've got the search icon as well. This will open also a dialog window where you can search for a name. We'll see that window as well in the next pages. And then we have a table here with these 4 columns: ID, name, course, and that would be the mobile number, the phone number. Then we have these 2 buttons here, edit record and delete record. Actually, these 2 will be inside an area known as the status bar. So this area here at the end in graphical user interfaces is known as a status bar. And yeah, basically that's what we have. Then you might start to document each of the elements. So for example, what do we have under file and what do we have under help? So for that, you can just write something like this. So file, and then when the user clicks on file, a drop-down list of sub-menu items will be displayed, such as insert new. So file will have only 1, help will have 2, like about and help, to show the information about the app and some help documentation as well. And then we have the other window. This is an insert dialog window, which is displayed when the user presses that button or when the user presses the file menu item and then goes to insert new. So this menu item here, insert new, will do the same thing as this button does. And that is opening this dialog pop-up window. Here the user, the teacher, will enter the name of the student. So they'll type something, they'll choose a course, they'll enter a phone number for the student and press submit, and this data will be stored in the database and displayed on the main window as well. Next we have the edit dialog, which looks the same as the insert dialog actually. So the users will be able to edit to update an existing record. Then the delete dialog. So this will occur when the user pressed that delete record button, which we saw in the main window. And so you want to show a pop-up window, a dialog window, asking the user if they are sure they want to delete something or not. So this is a good practice. You don't want to have the user accidentally deleting something, so you always want to display a confirmation window like this one. So we're going to be coding all these in Python, entirely in Python. The next window is the search dialog. So the user will enter a name here and they'll press on search, and that name will be highlighted in the main window. So imagine there might be many records. So it's good to have a function which allows the user to search for a specific name. Yeah, that's it. Those are the windows we will generate with Python and PyQt6, the library that creates these kinds of graphical user interfaces. So we're going to start by coding the very first window, which is the main window. So this one in here. So let's do that in the next videos. I'll see you there. Thanks. Hi, I'm excited to start coding again with you in this video. So let's create a new PyCharm project first. I've done that already. And then we want to install the PyQt library. So open the terminal and type pip install PyQt. Now there are different versions of PyQt. The latest version is 6. So pip install PyQt6 and press enter. That should install the library for you. You can close that terminal once the installation finishes. And then in this video, we want to start with a simple example, a standard example, just to introduce you to PyQt. So let's create a new file. I'll name this example.py. Later we're going to have to create a main.py file for our app. This is going to be just an example to introduce you to PyQt6, which can be imported as this from pyqt6.qt-widget import q application qv box layout and some other widgets. So what I'm doing here is I'm accessing the module key2widgets from the PyQt6 library, and this module has several widgets. So these are actually classes. For example, the QApplication class, which will create a widget. You'll see how that works. And other widgets as well, which we'll need, such as QLabel. We also have QWidget and some other widgets as well, but let's import these for now. We will import more when we need them. Now, to introduce PyQt6 to you, I want to build this simple graphical user interface, this program. So it will have only one window. So this will be basically an age calculator. We're going to have a label here, name, a text box, this here, another label in here in the second row, date of birth, and this format indicator. So the user can enter their date of birth in this format, month, day, year, their name, and then we'll press on calculate age, and that will display the age of the user based on the date of birth that the user enters here. So we'll display something like, John, you are 98 years old, or something like that. So that's the sketch. Now, to make that window, you want to use a class. So you want to use one class for each of the windows on your app. Now, this example has only one window, so we're going to have to use only one class. But for the other program, which I showed you previously, the main app that we'll build, which is the student management system, this app is going to have multiple windows. That means we're going to need multiple classes for this app. But let's focus on the age calculator app for now, which looks like this, so it only has one window. Now, what are these parentheses here? Well, this age calculator has to inherit from the QWidget class. So capital Q, capital W, so that's the class we imported in here. Why do we inherit from QWidget? Well, because a QWidget is a class which creates this kind of windows, right? We could also do this like age calculator is equal to that, and then create an instance of a QWidget. That is also possible, and then add some parameters here, and then add some add widget, something like that, add some methods, use the methods of that instance to add these other children widgets, so text boxes and the labels and so on. But the recommended way is to inherit, so to create a new class which is a child of that class. We do that because we want to add some more capabilities, some more methods, and we want to override some certain behaviors of the Q widget class. So creating a child class of Q widget is more powerful than just creating an instance of Q widget. Now you know that classes have an underscore init underscore methods, right? But we want to override that method in this case. Sorry, init. So we want to override the init method because we want to add some more code. For example, we want to start by creating a grid using QGrid layout, which is also a widget we need to import from here, QGrid layout. So we import that, we use it here. So we instantiate that, we create a grid, a QGrid layout instance. Then we want to create some labels such as the name label. That is going to be an instance of the QLabel class, which is this one in here. And this gets an argument, so this class can get the name argument. This is the label that is going to be displayed in here. So name with perhaps a colon or without a colon. I'll leave it with a colon there. So what we're doing here is we are writing what will happen when this class is instantiated, which is going to happen outside the class somewhere. So if you want to do it right now, you want to unindent, go to the very upper level of indentation, and then say age calculator is equal to age calculator. So this class. So we instantiate that. When you do that, you are executing all these. So you are building those labels and text boxes, which we'll add in just a bit. So we added name, and then we want to add name line edit, which is going to be Q line edit. This is also a widget, so let's import this as well. I'm going to type a comma here and a backslash, and that allows me to keep adding widgets for this import statement. So the next widget is going to be this QLine edit, right? Let's make some more space here, and this is better to be indented somewhere in here to be in line with the PEP 8 style guide. So QLine edit, this is the text box, and I'm going to select these and press on Ctrl D or Command D to duplicate them. And so that will be date of birth in YYY. So we want to tell the user the expected date format, and later you'll see that we'll get that format and process it. So let's call this date birth line edit. Right, so we have these widgets, and then we have this grid layout, which I haven't explained yet, but this is where we connect these widgets to that grid layout. So the grid layout is like the invisible widget. It's like a grid, we don't see it, but all the widgets now have to be added to that grid. So we refer to the grid variable and then to the add widget method, which is a method of a grid layout, of a QGrid layout instance. So there we add name label at the position 0, 0, right? So if you see here, this is position 0, 0, then this would be position 0, 1, then this would be position 1, 0, and this other text box would be 1. This age calculator here is just the title of the app, of the window, which we will add later on. But the grid is what we have in this area here. The grid is applied to this area, or in other words, these widgets are applied to the grid. So let's duplicate this. You can leave the cursor anywhere in this line, press Ctrl D or Command D. And so the next one is name line edit. We said that this would be 01. Ctrl D again. The next one is name label. This is going to be 10. Ctrl D. And the last one is this 11. I've done an omission here. Oh, this name label is being used twice. So this is actually, sorry about that, date birth label, which goes in here. Yeah. Right, what we have so far is 2 labels and 2 text boxes. But we need to also add the button and also a label area here where we'll show the results and also the title of the window. So we have 2 options. Either we keep adding widgets here, or we first run the app to see if we have some errors and how the app looks so far. And I would prefer the second option, because if you have some errors, it's easier to debug them right now. So let's try to run the app. You'll get an error. First, it says that you must construct a Q application before constructing a Q widget. So what we're doing here currently is we are constructing the Q widget, age calculator, which is a child of a Q widget. So we need to use that Q application which we imported in the beginning. So that Q application class should be constructed or instantiated, in other words, before this line. So let's assign that to a variable app, and inside here we should provide a sys.argv argument. Sys is a library, a standard library in Python which we need to import sys. It's short of system. The sys library provides various functionalities for input and output in the command line when interacting with a program. So this Q application class gets this as arguments, and this provides basically a list with the file name and other arguments which the user may pass when running the app, but these are some underlying aspects in special cases, so you can just leave it as it is for now. So we start the Q application, the age calculator, Q widget, and also you want to point to the age calculator variable and then to the show method, and lastly sys.exit app.exec. So app is this variable. Right, let me remove some space there. So that's the running loop of the app. This is what executes that code. Let's try to run it now and see what we've got this time. Run. We get this other error. Superclass init of type age calculator was never called. What is this error? What is the superclass here? Well, the superclass is the parent class, in other words. And this is saying that the init of the parent class should be called. And that's actually true, because what we did here with this method is that we overrode the init method of the original parent class QWidget. So QWidget has its own init method, right? And that init method has their own code inside which needs to be run for this QWidget to be actually constructed. But in our case, since we have overwritten that init method of the parent class, that means this method, our method, is called and not the method of the parent, right? So we need to figure out a way which calls both the parent's init method and the child init method. And that way is to refer to super dot underscore underscore init underscore underscore parenthesis. Super is a function which returns the parent of the class from which is being called. So the parent of hCalculator. And so that would be QWidget, this class, right? And then this method is the original method of the QWidget class. So now, before we run any of our code, we first run the init method of that QWidget class. Now we shouldn't be getting that error anymore. So let's run. Right, no errors. These are just messages in here. However, we don't see any of our widgets, labels or text boxes. That's because it's true that we added these widgets to the grid object, but we haven't added the grid object to the hCalculator widget, right? So we need to do that as well. For that, we need to use self.setLayout with capital L grid, the variable which holds the QGrid layout. Now, why self? What is self? Well, self symbolizes the instance, the hCalculator instance, right? So when you do this in here, so you are creating an hCalculator instance, right? So within the class, that instance is represented by the self variable. So basically you want to access the setLayout methods of the hCalculator class. Now, the hCalculator class doesn't appear to have that method, but the QWidget class has that method, right? So this method is inherited from QWidget. And so we access it with this here. Right, let's run again. Yep, and there we go. So that's our app. We have a name label, the QLine edit widget here, another label, and the other QLine edit widget. And as you can see, so the first two, these two are in the first row, row 0, so column 0, column 1, row 0, row 1. Yeah, that's what we've got so far. Let's move on by adding a button. Let's add it actually in here. So let's write a comment line here. Create widgets. Add widgets to grid. So we have different sections, right? So let's add a calculate button. So store it in a variable. Calculate button is going to be equal to qpush button. That's a class. Oh, let's import it. So comma qpush button, and we also need to add an output label which is equal to qLabel, the same class, but a different instance. Of course, you can have multiple instances of one class, so that's one instance, that's a separate instance. This will be a separate instance as well. You can just pass an empty string there, so initially this will be an empty label, but then we'll populate it with the age value, which is going to be part of a function. So the operations will be part of actually a method, not a function. A method of hCalculator, which we will write in just a bit. First, let's add these two to grid. So grid add widget. So that's calculate button. Let's add it to row 2, right? We have row 0, row 1. Now we have row 2, column 0. Oh, so what do we do now with the button? Because basically we want to add the button somewhere in the third row, but we want to have it span across both columns. So somewhere from here up to here, right? To do that, you want to specify that you want your button to span across one row and two columns. So let's see what we've got. Yeah, that's the button. Without a name, we can add a name. But basically this is what I did, so it spans across one row. So let's add a label to the button. Calculate age. Right, that should do it. And then grid add widget. That would be output label. That's row 3, a column 0, and spanning across one row and two columns. Run. And yeah, so we have the button, which doesn't do anything for now. And then we have the label area in here, where we'll display the output. Now, that was the init method. So the purpose of the init method is to construct the widgets to display the initial window to the user, right? But we don't want to calculate the age in the init method, right? We want to do that when the user presses this button. So we want to say when calculate button dot clicked dot connect, so when the button is clicked, we want to connect it to the self dot calculate age method. So that's a method we need to add now, just after init. So you want to have one level of indentation and write diff calculate age, right? You can see the benefits of having classes, working with classes. You can see that you can keep all the data and the methods of one window, one class, within the same entity, which is a class, right? So now, calculate age. Well, to calculate the age, we basically need the year of birth of the user, and also the current date. So to get the current date and time, we want to import from date time, import date time, right? So then we can get the year like this, from date time import date time, and then you say date time dot now dot year. That will give you the current year. So we get that code, we say here current year is equal to that, right? And then we want to extract the year of birth, which is going to be that variable, right? That's a variable which is equal to QLineEdit, and that's a variable which contains the value that the user will enter. Well, actually, we need to add a text method to that to extract the value. But first we need to get access, to get our hands to this variable, which as it is now, we cannot access it, right? So if you write that there, you'll get this red underline. So Python cannot see that variable from this function because that variable is a local variable of this other function. Yeah, these are methods, but they behave like functions in the sense of the scope. So we need a way to make this variable visible to this method. And that way is to make this local variable an instance variable. Instance variables are those which come after self. So by doing that, you're saying that this is part of the instance, the class instance, right? And that means you can access now that instance variable from this other method, and that will be fine. But make sure that you have also changed your other variables into that format, right? Because this was referring to this local variable, so now this also has to be self.dateBirth line edit. So this attribute, the dateBirth line edit attribute, is created in this line. So an attribute or an instance variable, whatever you like to call it, that is created in this line, then it is used in this line, and also it's used in this line in here. And then we said that we need the text method to extract the actual value from that Q line edit widget, right? So now we have that in year of birth, we have the current year, age is going to be equal to current year minus year of birth. Then what do we do with age? Well, we access the output label, which again we need to convert into an attribute. So self.output label, also make sure to convert it here as well. Self.output label, and then you say self.output label dot set text. So set text is a method of a QLabel class, right? So we set the text to be a string where you could say something like a placeholder first is years old. So I'm trying to extract the name as well. So this is going to be age, this variable. So that's an f string, right? And this first argument is going to be the name of the user, name label, which also needs to be converted into an attribute. So self.nameLabel, self.nameLabel. Right, we're almost done. Here, year of birth, and we are getting the entire date of birth from the user, so we need to extract only the year from that. So to do that, let's call this date of birth, and year of birth is going to be datetime dot strptime. Date of birth goes in here, which is going to be in the format of month slash day. This is what we expect from the user, and year with a capital Y for year, dot date, and then year. We extract the year, right? So what we're doing is we are converting the string, the user date string, into an actual datetime object using this method. And then finally we get the year from that. So yeah, let's run. John, date of birth, let's say 12/12/1943, calculate age, and oh, we're almost there. PQT, the name actually is wrong, self.nameLabel. Oh, that's because I actually got the name label, and perhaps you know that I shouldn't have cut the name label, but this one, sorry. So let's convert that back to a normal local variable. So we need self.nameLineEdit. Self.nameLineEdit.text, the method which extracts the actual value. So let's run again. Actually, we want to restart the running process. 12/12/1943, calculate age. John is 80 years old. And just before I close this lecture, there's one more line of code I want to add here. So please go somewhere in here, and under super, you want to do self.setWindowTitle. So this method will set the title for our window. For example, age calculator. If I run the program now, you'll see that the title is here at the top of the window. So that successfully finishes this program. So let me quickly do a revamp of what we did. So as you saw, a window is represented by a class, and that class has to inherit from a Q widget. And inside the init method, you construct that particular window. You define how you want the window to look like. And if you want to make some other operations, such as calculations and other processing of data, then you want to add methods. So that's what we did. We added a calculateAge method, and then at the end here, we have the lines. We'll basically instantiate this class and call the necessary methods, which are basically routine calls that you always have to do to initialize your program. One last thing is, we used a QGrid layout for this example, but you could also use a QV box layout instead of a grid layout. The difference is that QGrid layout gives you more flexibility to position, to distribute the widgets, but QV box layout only lets you position the widgets stacked on top of each other vertically. You also have the QH box layout, which allows you to position widgets horizontally, but basically QGrid layout is more powerful. So you can remove that QV box layout from there, since we used QGrid layout. And yeah, there you have your first program with PyQt6. So good job, and I'll talk to you in the next videos. See you there. Hey, welcome to today's project. Your task for the day is to build this application. The users in this application can type in a distance, for example 10, and that would be in kilometers if the user has selected metric in the drop-down list here, or if they choose imperial, then this is read as 10 miles by the program. And then the user can enter the time, for example 2, so they completed 10 miles in 2 hours, and then the user presses calculate, and that will calculate the average speed. So 10 miles in 2 hours, that would be 3.11 miles per hour. If the user chooses metric and they type something else or leave the same values there and they press calculate, then this should be updated to 5 kilometers per hour. So that's a program you should build. Now there's a hint attached in the lecture resources in this lecture. There you can find some sample codes on how to construct this combo box. So this drop-down list here, also known as a combo box, you can find the code in that lecture, and then you can implement that code in the application you will build. This is quite a fun application to build, and this will solidify your skills about PyQt6. So good luck. See you in the solution video. Hi, this is my code to build the average speed calculator app. So that's an overview of my code if you want to stop the video and take a look. And let me quickly explain what it does. So I imported all the widgets in here, and since I created a class inheriting from QWidget, here I instantiated the QWidget parent class. I set a title for the app. Then I used a grid layout here. I created some widgets such as a distance label widget, QLine edit, which correspond to that, and then the other label and the text box here as well. Then I've got the combo box with these 2 lines in here, which reflect to that combo box there. Then next there is the button with these 2 lines, and then the empty label, which is below the button. Then I added all these widgets to the grid layout, and then I added the grid layout to self. So self is the widget, the Q widget, the main widget, and then I have the calculate method. First I got the distance and time from self.distance input and self.time input, the two text boxes that I created up here. I made sure that these are converted to float, otherwise the type of the values entered by the user will be read as strings. Then I calculated the speed using those two. There you go, maybe some space between the two. Then I check what the user has selected in the combo box. If they selected metric kilometers here, then I applied this rounding to the speed I calculated in here. Otherwise, I added this coefficient, so I multiplied the speed by this coefficient to convert it into miles per hour. Perhaps you did it differently. It doesn't matter if we both have the same results, more or less. So that's the result label. So I set the text to this invisible label, and that will display average speed and the units after that. And these are the routine calls which initialize the application. And yeah, that's it. Thanks for following, and I'll talk to you in the next day with more code. See you there.